Hello, Math 3 students. We are nearing the end of the rational functions unit, and this is week 2.6. I know it says math unit 6, day 6, whatever. That's just from an old, it's from an old set of notes. You can mark that out. So you can mark that out if you want to, if you don't like the way it looks. So this is notes 2.6.3. Yesterday was election day, and so you're coming back in today. And we have 2 days of applications, in other words, word problems. These are actually called these are what we call work problems instead of word problems. So, and they're all kind of work the same way. I didn't really go through rational expression equations, but you're going to kind of get a crash course in that with these problems, and they're not too hard to do, and they're actually a lot easier than those addition and subtraction problems we did. Because there's not a lot of room between these problems, I'm going to make this like 400% and see if I can see the whole problem. If I do that, I think I can. Yep, I can. Move this over a little bit more. Okay, so I'm just going to start with the first problem. There's not really any notes with this. It's just me working problems and telling you how to work them. So I'm just going to start with the first problem, and we're going to do as many as we can in like 30 minutes, and then I'm going to stop. And you're responsible for what I do. Okay, let me get a different color, and I'm going to make this like 0.25. That might be the best width there. So the problem says, working alone, Castell can sweep a porch in 8 minutes. Crystal can sweep the same porch in 11 minutes, and then we're supposed to find out how long it would take them if they worked together. So, you know, you might think, oh, 8x plus 11x. No, it doesn't work that way, unfortunately. The way we set this up is with a fraction, with a ratio. That's why these are rational expression applications. So if I say, okay, Castell, I'm going to just put a C here for Castell. Castell can finish this job, this one job, in 8 minutes. So it takes him one job to 8 minutes, okay? And then Crystal, let's do a different color for Crystal. Crystal can finish the same job, that same job, in 11 minutes. So each of them can do the one job in a different number of minutes. So that's kind of how I set that up. And then together, we don't know how long it would take them, so we would put that same one job, because the one is the same, because it's just one job, whatever it is, sweeping a porch, cleaning a house, whatever, it's one job. But we put an X for the unknown, just like we would in any type of problem like this. And so what we want to know is how long would it take if they work together? Well, together means you add things together, okay? So then what I'm going to do is I'm going to take the 1/8, add the 1/11, and figure out, whoops, what color did I have? Oh, that one. What X is, like this. Okay, so this is the way we do this. You remember when we added and subtracted, we had to find a least common denominator. So that's what I have to do here. Now, my least common denominator for 8, whoa, that's huge. For 8, 11, and X is going to be just all of them times each other, okay? So another way you could write this is you could write it like vertically, 1/8, 1/11, whenever X, that you might like that better. So the least common denominator is going to be 8 times 11 times X, okay? So 8 times 11 times X would be 88X. All right, so let's look at the 1/8. What do I need to do to 8 to get 88x? Well, I would have to multiply it times 11x. Okay, so if I do that in the denominator, got to do that in the numerator. All right, what would I do to 11 to get 88x? I would multiply that times 8x. Okay, and then what would I do to x to get 88x? Well, there I would multiply times 88. It's not always all of them times each other, but this time it is. All right, so now let's take this part right here and rewrite that expression, this part, and rewrite that expression, and this part and rewrite that expression. Because we got to do the multiplication before we can do anything else. 11x over 88x plus 8x over 88x equals, what color was that? Oh, that one. 88 over 88x. So here's what I did in the numerators. I did this right here, 11x times 1, and then the 88x goes on the bottom. And then I did 1 times 8x, and then I did 1 times 88 for that kind of periwinkle color, whatever that is. I don't know what that is. The second purple color, or the hot pink. I don't know what it is. Whatever. Magenta. That's it. Yeah, magenta. All right, so now what I want you to look at is the fact that all of the denominators are the same. Okay, so if all the denominators are the same, I can mark them out. I can forget about them. And then I can just do this right here as an equation. Okay, and that's really easy. 11x plus 8x equals 88. 19x equals 88. Divide by 19. We're going to get a decimal. X equals, what is it? 4.63. And what was the unit? It was minutes. So that's it. That's all there is to that. You got to find that least common denominator. That's probably the hardest part. But there's the answer right there. Where is number 2? Is it down here? Nope, it's over here. All right, same, very, very similar problem. It's asking how long would it take them to work together. So I'm not going to do different colors this time. I'll just use red. Eugene he can build a home, which is that one job, in 10 weeks. All right, Lisa can build the same home in 15 weeks. How long would it take them if they work together? So Eugene plus Lisa equals together. What is my LCD, or my least common denominator? Well, here I don't have to multiply the 10 times the 15 because there's another denominator that I could use. I could use 30. And so that would work if I use 30x as my LCD. All right, what do I do to 10 to get 30x? I multiply times 3x. What do I do to 15? Multiply times 2x. And what do I do to x? Multiply times 30. All right, so 3x times 1, 3x over 30x, plus 2x times 1. And then that equals 30 over 30x. You don't even have to do this part right here if you don't want to, because you know you're going to end up with the same denominator. So 3x plus 2x equals 30. That's 5x equals 30, and that would be x equals 6, and that was in weeks. They don't always ask, like, how long will it take together. Sometimes they'll give you the together number, and we might get to something like that. If we do, we'll kind of switch up the way we're doing it a little bit. Okay. Another one. Pretty much the same type of problem. The hard part, the trick, is finding the LCD, finding that lowest common denominator. Jennifer can mop a warehouse in 10 hours. That's one job in 10 hours. Molly, one job in 9 hours. And then together, we don't know. One job in how many hours? What's the LCD here? I think it's got to be 90x. What do I do to 10 to get 90x? I multiply times 9x. So this one is going to be replaced with a 9x because it's 1 times 9x. What do I do to 9 to get 90x? Times 10x. So I can just put that there. And then times 90 here. Get rid of all that. let's see, what's my decimal here? 4.74. And it was hours. So together, and that kind of makes sense. Think about it. If it takes one of them 10 hours and the other one 9 hours, how long does it take them together? Of course, it's going to be less hours than it took one of them. 4.74. It's not even an average, though, of like the two. It's not anything like that. So that's number 3. Let's look at number 4. Same thing. Pause your video and see if you can get this one. Perry takes 10 hours. And look, sometimes they'll give you information that's not needed. Look at this. 10 foot by 10 foot hole. You don't even need to, that's not even really part of the problem. It could just say dig a hole and it would be the same. Okay. So pause your video and see if you can get this. Okay, let's see how you did. I got 1/10. Perry, I think his name was Perry, was 1/10. Yeah. And then John was the 1/8, and together they were 1/x. You could have used 80x as your LCD, or you could have used 40 because they'll go into, both of them will go into 40. But if you've noticed, what ends up happening is you end up putting this number up here and this number up here, and then they both get the x added on, and then both of the numbers times each other end up right here. So it's kind of the same every time for this type of problem. So you should have gotten 4.44 hours. Number 5, let's see. This is the same kind of problem. It also says 10 by, okay. Again, remember to just ignore the stuff that you don't need. You don't need that. You don't need to know how big the hole is. It doesn't matter. So Crystal takes 9 hours. That's 1/9. Heather takes 8 hours. And together, they want to know how long it would take together. So the 8 ends up right there with the x, 8x. Okay, I'm gonna do that down here. So 8x, and then the 9 ends up here, plus 9x equals, and then multiply them together, 72x. And then just solve for x. So that's kind of the pattern that they take. 17x equals, whoops, that should be 72x, sorry. 72 divide by 17. X equals, what number was this? 5. 4.24 hours. I don't know how, I don't know if they're all like more decimal places than that, but you can just round to 2 decimal places. Okay. All right, this one's a little bit different. Okay. So this time we have the working together number. So let's see, Matt and Leah. So we have Matt and we have Leah, and then we have together, just like we always do. But this time we're given 4.24 hours for the together number. Okay, so this time we have this number, whoops, 1/4.24. So we have that number. Had she done it alone, it would have taken Leah 9 hours. So Leah is 1/9. Matt is what we don't know. Okay, so this one's a little bit different. So this time it's 1/x plus 1/9 equals 1/4.24. You would still do the same thing to get the LCD. It's just going to be a little bit different as far as where the numbers go. So let's talk about that. Let's multiply x times 9 times 4.24. 9 times 4.24 is 38.16. So 38.16x is the LCD. Okay. To get x to be 38.16x, you multiply times 38.16, numerator and denominator. Okay. To get the 9 to be that, you would multiply times the 4.24, just like we did on the other ones. It's just they're in different places. So this is going to be 4.24x. And then the equals is going to be, let's see, that's going to be times 9 times, no, I'm sorry, 9x. 9x, okay. And this one over here is not, I'm sorry, the one on the left, we don't multiply it times the x because we don't need to get that numerator. But the 9 is going to be, okay, so here's what we end up with. 38.16 plus 4.24x equals 9x. So now what we have to do is recognize that we need to subtract 4.24x on both sides to solve for x. So 38.16 equals, I don't know what that is. Let me see. Get my calculator. 9 minus 4.24 is 4.76. Divide by 4.76. 38.16 divided by 4.76. Let me see if I got the same answer as my key. Yep. So x would be 8.02 hours. And this would be the number of hours that it would take Matt. And so this is how long it would take Matt. That one's a little bit different. It's really the same kind of concept. Just understand that, like, I'm trying to get all of these numbers, all of these denominators to be that. And over here on this one, I would need to just multiply times the 38.16. And I put that by mistake. I shouldn't have put that right there. Okay. And then it would have the x in the denominator already. Okay. We're at 17 minutes. We might can get like 10 done. Okay, let's see, what do we got? All right. This says Jacob can pick 40 bushels of apples. Again, the number doesn't matter. It doesn't matter how many bushels of apples it was. He can do this one job in 13 hours. So Jacob can do the job in 13 hours, okay? It's asking at the end, if you notice, how long would it take Leah to do it alone? So Leah alone is our unknown. And then together, this says, one day his friend Leah helped him, and it took 5.32 hours. So together is the 1 over 5.32. So it would be 1/13. And I'm going to make some space here so I can, over 1x equals 1 over 5.32. So I need to multiply to get my LCD. I'm going to multiply 13 times 5.32 times x. $69.16 x. 69.16x. Okay. So what do I do to, let's look at the x first. What do I do to x to get 69.16x? Well, I multiply it times 69.16. So I need to multiply the 1 times 69.16. Okay. What do I do to 5.32 to get 69.16x? I multiply that times 13x. Times 13x right there. What do I do to 13? I multiply it times 5.32x. Okay, so this right here is 5.32x over, and I'm just going to kind of go back to where we were at the beginning, over 69.16x. Okay. Plus this right here, if I multiply it, 1 times 69.16, 69.16 over 69.16x. All right, last color, let's do this one. This right here equals 13x over 69.16x. Now, I see that I have all the same denominators, so I can actually forget about those. This is what we did at the beginning. I just want to make sure I'm going slow enough where you see what I'm doing. So when I forget about the denominators, then what I can do is just use my numerators and solve for x. So I had 5.32x plus 69.16 equals 13x. Okay, so how do I solve for x? I need to subtract 5.32x from both sides. And so that gets rid of it there. 69.16 equals, and I haven't done that math yet. Let's see what that is. 7.68x. Now I divide by, and it, you know, the x is on the right side, but it doesn't really matter. Divide by 7.68. And that'll give us what x is. 69.16 divided, whoops, 69.16 divided by 7.68. I get 9.01. Let's go back up. Oh, here it is right here. The question was, how long would it take Leah to do that job alone? So this is how long it would take Leah. I see I've got a problem right here, number 9. Oh, okay. Same characters or same people in the problem, but different numbers. Okay. Perry can mop the warehouse in 12 hours. Perry is 1 over 12. I'm going to do this horizontally this time. We want to know how long it would take Castell to do it alone. So Castell is my plus. Castell is the 1 over x. Together, it says one day his friend Castell helped him and it took them 5.74 hours. And this is together. Just looking to see if we had already done one that had those numbers, but we didn't. Okay, so 1/12 plus 1 over x equals 1 over 5.74. What is the LCD? The LCD is 12 times 5.74 times x. $68.88. Okay, so we already know that 12 times 5.74 is 68.88. So the 12 is going to end up here. I'm going to end up marking the denominators out. The 5.74 is going to be up there, and 68.88 is going to be up there. These are both going to have x's on them. I'm just trying to shorten this a little bit. 5.74x plus 68.88 equals 12x. Subtract this. That is 6.26. We'll just say 11. 11, was it hours? Yep, hours. And that was how long it took Castell. All right. think we've got, let me look and see. These are all so similar. So here's one thing I want you to do. I want you to mark out 17 through 20. And I'm going to give you the answers to 9 through 16, I think. Yep. All right, so I'm just going to give you the answers. You don't have to work these out. I'm going to give you the answers. That way, if you wanted to practice any of these, you could. You will have a quiz on these. And look how small that writing is. And you'll have to do problems like this on Friday. All right, number 9. Number 9 is 15 minutes. Number 10 is 11 hours. Number 11 is 9.2 minutes. Number 12 is 13.32 hours. Number 13 is 13.69 minutes. Number 14 is 8 minutes. Number 15 is 15.41 hours. And number 16 is, oh, no, mark out number 16 too. I'm just not going to do any like that. We're just doing these work problems. That's all I wanted to do. Okay, so that's your answers for the last few problems. And we're almost at 30 minutes anyway. So, okay, so that's how you work. That's how you do these work problems. The ones where it asks you how long it would take if they work together, those are a lot easier than the other ones. But just remember, once you get the denominator the same, you can mark out all the denominators and just set up an equation with just the numerators. It's kind of like, well, I don't know if I even showed y'all that, but when you were doing exponents, if you got the bases the same, you just set up the exponents as an equation. So it's very similar to that. So of course you will have a mastery check on this, and the link will be at the end of this video. If you come to the live lesson today, I will be working a couple of the mastery check problems for you.